Today the talk will be about Quarkus. And not only Quarkus in generic, but also Quarkus applied in production project per se. And when it comes to agenda, we're gonna first go through what Quarkus actually is and from where it's coming from. Why is the need of Quarkus so important for Java space, especially? But we're going to look at the good and the bad things, because there are also some bad things when you go to production with things. We're going to look a bit of some generic metrics to understand how performance of Quarkus actually is. And we're going to go in some takeaways also on the developer side, but also on the architectural side. So being a solution architect, it's always important to know what you kind of propose as solutions that can go nicely in production. And we're going to go in a coding session as times allow to kind of show you why I think Quarkus is quite a good development tool, especially for developers to learn. And speaking about Quarkus, maybe we should go first in history to understand how Java space evolved and software development evolved over time. So 10, 15 years ago, we've been in local data centers with a lot of monoliths in the play. And yeah, the resources you consume weren't so important. So in the data center, you buy the software once every couple of years. You have the hardware at use, so you use the resources or not. There's really no additional cost for you. So in that space, what's important is to have processes that are running on long periods of time with very high performance without any bottlenecks or any downtime. And Java was actually created at that time with that KPIs in mind. So Java is very stable in time. The big problems you had in the past with Java were like, do you have any memory leaks that is kind of putting your system down? That was the big problem you had. But in the last 10 years, and especially in the last 5, people are moving a lot towards microservices. And yeah, the patterns of microservices are nice, but also the costs that come associated with microservices, that's also important to notice. But I think the big driver is actually the cloud deployments. So moving everything to cloud makes us think a lot more about the resources we consume with our infrastructure, and that's why microservices is kind of also a business important topic, not only from the technology point of view. And how Java copes with that? Well, Java is not so good with ups and downs on the system level. So with the JIT compiler, it's very good after it's warmed up, but before it's warming up, until you kind of start everything in a Kubernetes environment, that's taking time, right? So Java is not the perfect thing for microservices already, but it's still on the top of the game because the ecosystem around Java is extremely mature and has a lot of tooling, and kind of the ecosystem is making Java great on the microservices space. But moving further in the future, probably serverless will be more and more used, and not because of the pattern itself, but because of the business. So you need to kind of optimize more the resources to get lower running cost. And also microservices are not so easy to maintain. You have a lot of DevOps requirements to handle that. And serverless with AWS Lambdas and things like that, gonna make it quite easy to optimize costing, right? And but that's so if you go to serverless, Java, it's also not so good at that, right? So boot up time is quite important for serverless. So serverless should be up and running in milliseconds. You should be able to serve requests and go to a dormant state as soon as possible, which Java is not at all good at. And yeah, new technologies need to be created around Java space to be able to cope with serverless if we want to keep Java still alive for the serverless world or the next 10 years as well. And to understand a bit more the problem that Java has, you need to look a bit what's happening actually on runtime, why Java needs a lot of time to to be able to do things, right? So we have a startup overhead that is quite big on Java, and there are a lot of things that's happening there, from class path scanning and jar loading and all that. But the big problem is the dynamic compilation that happens there. So you have a lot of drivers on the database. You have a lot of logic to kind of manage any type of database on runtime, but actually what you use in production is basically one database. So you have a lot of logic that is happening in the dynamic part of startup in Java, which not necessarily you need to have there always. But yeah, it's flexible, but not so optimal when it comes to startup times. And also RAM, it's important on cloud, at least for AWS Lambdas, but I think for pretty much all the systems that are doing serverless, RAM, it's a driver of cost for resources, right? But also when we look at Java systems coming from 10 years ago when memory wasn't so important, we looked very specifically on what heap is, what heap occupy is, to kind of optimize that for garbage collection and all that. But if you look at the entire picture of the RAM allocated in a pod, there is not only the heap that it's important, also the meta space where the classes and metadata in compilation, it's actually eating up a lot of space. So if you look at the container overall, you kind of get a lot of RAM used, not from the heap specifically, but all the internals of Java as well. And now Quarkus tries to kind of tackle all those topics. So let's say the marketing label for Quarkus is that it's supersonic, it's subatomic, and it's still Java. What supersonic should address, it's the startup times, right? So to be extremely fast on startup. Let's see if that's handled. Subatomic, that means that the RAM and memory consumption and disk space even it's a lot lower than normally it is, and that's important as well on the cloud space or on the cloud cost overall, right? But what also Quarkus tries to achieve is to be fully Kubernetes native. What that means is that you shouldn't have any kind of problems to put them in containers, run them, scale them, boot them fast without any kind of problem. Let's see how I see that. So this is the generic statement. But for me, Quarkus is four different things, quite important per se. I think Quarkus is a very good building tool. So it's doing optimization on compile time, even though still Java is trying to kind of avoid a lot of post runtime processing by moving things on the build time. So it's optimizing a lot the compilation to get better times on the runtime because of the way compile happens. It's also a framework, so it's coming from the Java EE space. So it's kind of putting everything, all the wires together on the Java EE space to compile it in a complete framework. But it's adding on top of that all the cloud things that Java EE miss, like micro profiles or Eclipse micro profile implementations, and also everything around that, tracing, caching, BPMN, and everything around tooling that make Java the best ecosystem to work on cloud. And it's also tackling the native image part, where the boot time is kind of going to 0. And if you know the Graal VM project, where you kind of try to compile Java code in the native image to make it faster to boot and faster to run, they are trying to do that. But if you are familiar with that, and if you try to use Graal VM in projects, then that's not an easy task to do. You need to kind of, for all the libraries you have, you need to do things to make them compatible with native compiling, which is not so easy to tackle in a project. So Quarkus is trying to kind of provide a set of extension and tooling that it's already native image optimized, and yeah, you kind of have that granted. So you can, if you use Quarkus, you can go to native images without any additional costs. And the last thing, but I think is quite important for the session we are in, is try aims for a better developer experience with a more simplified coding. And I will explain a bit in the demo how that works. But I think it's one of the biggest, the most important things for adoption of Quarkus long term. Looking at the Quarkus build structure, so this is what's happening behind the scenes. So it's Java usually, so you compile to classes, but Quarkus goes with a Quarkus plugin that is optimizing the jar for runtime operation. So what you end up, it's either a jar that it's more optimized than a normal JDK jar. So basically, you should get a bit of performance out of that when it comes to startup time. But if you want to go native, you have another component of the build of Quarkus, which is relying on Graal VM to do native image compilation. That's given. So if you kind of go with Quarkus, you have the native image possibility without any additional development effort that you would need to do. Okay, now going to Graal VM. So I don't know if you're familiar with Graal VM, but basically Graal VM, it's a OpenJDK based implementation of Java Virtual Machine and JDK that is based on Java and has JIT compiler done in Java, but also has ahead of time compilation support. So you can do native image on top of that, but it's also a polyglot JVM, meaning that you can run any or multiple type of programming languages on top of that. And you have Python, Ruby, R, and you have also Node.js and all other stuff. Just to give a bit of context on that, but I will not go in more details on Graal VM. I think that's a topic for a completely different session. And now let's go in the details a bit with the good and the bad. And I split the good things on developer specific and architecture specific, because I think the developer gains are rather more important than the architectural gains. And what you get as a developer, you have a hot reload, a very good hot reload that is easing up a lot the productivity for developers. And this is active only on development profile. You have a very nice and friendly error exception handling management, and we're going to see in the demo today how that's handled, because you're not going to get only exceptions always, and you kind of need to track the root source of an exception, but you're going to get even, let's say, hints for you to kind of understand how to fix your exceptions or your errors on the build time. You have a build time optimization because Quarkus is actually managing all the extension and all the systems around that, like, I don't know, JDBC interaction or Hibernate interaction. So it's going only one pass of optimization. So it's going one time on the compilation to kind of improve dependencies, and basically the build time overall are gonna benefit out of that. We have a unified configuration for everything. So basically one single configuration file with a lot of defaults to boot start very fast the applications. And of course, you have the native compilation as given, but what you also have, you have the wireframe, the structure for even creating Docker images, deploying Docker images in Docker containers, even generation of automatic YAML files for Kubernetes. So all that will be kind of in there. From the start of the project, and we're going to try to deploy a Docker container to see how fast we can actually do that. And also, if you are a fan of Spring, and I think adoption of Quarkus is highly dependent on the Spring knowledge that everyone has in our days. You also have support for Spring annotation, so you can even keep with your annotations from Spring MVC or Spring security and still be able to do coding on Quarkus. When it comes to architecture, not so many things, but quite important stuff. So we lower the consumption of memory by some quantity, not as big as we thought, but we get some gains on memory. we get a lot better startup times, even without the native approach, even with the Java jar, that's still good performance. And what's also nice, being a new technology, it's based on a fully reactive approach. So everything inside the core, it's reactive and non-blocking. You can go also on standard, but you have the reactive always as an option. And as you know, for Spring, you kind of, if you go reactive, you cannot undo that. So you are on reactive all the way. But here you can kind of pick and choose depending on what you like to use. So it's a lot more flexible than other solution out there. But of course, after a couple of years of this project, there are a lot of not so good things. So that's why the adoption is not at the level maybe people would expect, is that the coverage on extensions, so Quarkus being so dependent on exceptions to get the performance, extensions coverage is the most important part of adoption, right? And extensions are covering most of things, but not all things. And you need to be very careful when you go that path to make sure that extensions are available. Otherwise, the gains on performance maybe are not at the level you would expect. Documentation, it's a very good for a starting point. It's very well documented. But when it comes to like corner cases, if you are working with Spring, so you kind of find everything for everyone in the space. That's not the case with Quarkus, and that's mainly because of the adoption of the framework altogether. There is no front end officially released, but since probably you're going to use it rather for exposing endpoints, that shouldn't be a big blocker. But I think the biggest problem is the adoption, that it's kind of driving also the lack of knowledge on the development teams, and also a lack of trust in documentation around the framework. And now let's look a bit of the metrics. So how in reality this looks like. And I will advise not to look in specific numbers, because that depending a lot on maybe machines that you run the test or whatever. But maybe to look at the variation. So I compared here the Quarkus native, the JVM, and the Spring Boot in the same level, not on the full project scale, because yeah, it's hard to kind of do Spring Boot and JVM at the same time, and Quarkus JVM at the same time with a full production application, but with a limited use case. So for the container startup, right? So first request to return results, we see that the performance on JVM, it's extremely good compared with Spring Boot on the first run, but the native, it's outstanding. So Quarkus with native, it's outstanding on the boot time. So this can be a good solution probably for the serverless approach if we go that native way. If we look at the memory consumption, it's of course also on the native side a lot better. And when we look at memory consumption, it don't look only on the heap, but on overall, let's say, process memory that it's used by the running setup. And we see improvements also on the JVM approach. Probably that's coming because of the optimization that's happening with Quarkus, which is kind of moving away from the compilation path. A lot of classes that are not used on the execution path. So probably that's why the memory it's a bit less. But of course, we expect that the native part will gonna have a lot less memory consumption. And you would expect that with that approach, so we're going to have fast boot up time, but JIT will going to pick it up on the JVM side, and the performance on the JVM will be rather better on the longer run when it comes to the overall process operations, right? I run a bit of tests when it comes to get and post operations with JMeter around 10K of calls in 5 minutes time, and the things are kind of even up. So you see the response times are quite on par. The differences are quite small. So I would say that there is no any, let's say, average time responses for get and post operations when it hits the database. There is no much difference when it comes to Spring Boot, maybe a bit better, but yeah, that's too close to tell. But generally, also the performance over time seems to be quite good on Quarkus. Then let's think about, so my takeaway. So being a solution architect, I'm rather looking at a solution to propose for different use cases, right? So it's a nice tool. It's on paper looks nice, but how do you apply this actually for a project, right? So it is a good solution or not. And I analyzed a bit from my perspective, let's say, if I would propose Quarkus in different aspects. And when I look at microservices, so if I need to provide a solution with microservices, is the Quarkus the solution to go? Well, there are cases when it is, but you need to be very specific. So you need to know the libraries where the system will going to be developed to make sure that you have coverage with that. You need to gather a team of developers that have knowledge working on Java EE rather on the Spring, because if you are having team that is Spring aware, then Spring Boot will going to be maybe better on the back end, so to kind of deliver a better value. So I would say that Quarkus on microservices, from my point of view at the moment, cannot be like the hands-on winner, but can be proposed in some specific use cases. Well, the story is kind of inverted when it comes to serverless. So serverless is highly dependent on startup time. So serverless needs to have containers very fast up and running. If you do warm up to them, basically you lose resources. So you kind of defeating the purpose of serverless altogether. For now, since Spring Native is not yet productive, so probably will be at the end of the year, Quarkus on Java space especially doesn't have a powerful par comparison. Of course, looking on Java space, it's a winner. But if we kind of extend a bit and look also on Node.js, on other technologies that can cover this part, then yeah, the problem kind of switches a bit. But when it comes to Java technologies, probably on serverless would be the way to go. When it comes to project migration, again, very hard to propose Quarkus because mainly of limitation on libraries. So Quarkus is very specific on the libraries it's using. So coming with the old system that you want to migrate implies that you want to change a little as possible to not have any impact on operations. So Quarkus is very hard to kind of propose it for migration projects. But what I like the most on Quarkus is that it's, for me at least, is hands-on the best solution I would pick for functional POCs or for things I want to develop without any, let's say, assuming responsibility on production or the risks that are associated with the production system, right? And that's mainly because of the experience as a developer and the experience when you code with Quarkus. So, and I think one of the problems that Quarkus has is the community of development is not so big. People are not so aware about the technology. And if more and more people are going to kind of touch Quarkus, at least to play, this will going to get more and more adopted by everyone. So I will conclude with that. Let's say the high level discussion about Quarkus and the experience I had with it and how I propose Quarkus or other solutions when it comes to architecture. And to explain a bit more why I like so much Quarkus when it comes to coding, I will go to show you a bit of that. And I will just move that and go in the IDE. So Let's look a bit what you actually need to start doing stuff. So you need a plugin first. For I will use IntelliJ, but pretty much all the big IDEs have support for Quarkus. Plugin, it's Red Hat specific, so it's from the source. To create a project, just new project, you have a Quarkus option. You hit next, you just put your details of the project here. Let's give it a name. And these are the extensions that I spoke about, and I will go with REST Easy Classic just to initially to kind of expose an endpoint. You have reactive for pretty much anything. So as you see, so the reactive is a big word for Quarkus. And if I hit next, generating the project, and that's pretty much it. So I should have already the project here. And what I will get from that, let's look a bit on what we get. So in the POM, so it's a Maven specific. In the POM, we get some dependencies. We see that everything is Quarkus specific, but if we look on the dependency, we actually have underneath the hood, you have all the big libraries on Java EE space. So it's basically a shell to support the native part of things, but under the hood, it's basically using the big libraries that you always use in projects. When we look at what you get from SRC point of view, you get Docker file already. So you get JVM and native Docker file, and I'm going to use it right away to create, so to actually build our image in a native way already. And I will just open, because the running of the native image is going to take some time. I will just start with that. Just to show you how it's done. So basically nvn package -p native, so it's a profile for that. And the generic advice that we get is to run it like that. When you run it like that, you kind of get it in the for the local machine. But as you see, I have a Windows machine at the moment, so that's not so possible on Windows. But usually what you want to do is kind of put this in a Docker container. So you want to have an image for Docker container, right? And to do that, you just put this parameter, so Quarkus native container build true. And what this is doing is actually getting a container for you, which is Linux-based container, and you can use that to kind of deploy it in Docker, put it in Kubernetes, and do your stuff with it on a native level. And once this is working, and we're going to take 1 minute or so, I will go through to the rest of things that we kind of get out of this. So we have already a basic endpoint that is kind of showing us a message. Not big deal about that. We have application properties, which is working a lot with default, so we don't have any parameters defined here yet. But we also have a TDD approach. So we have also a test already created for us for the endpoint we exposed, right? So it's pretty much everything here. And you can even run it immediately. So you just build and run, and everything it's up to speed for you. So what I have as a setup here, so I have Docker desktop. This is the image that was downloaded. I was downloaded this couple of days ago, but this is the image that will be used for a native compilation by the system. So a couple of more seconds for us to kind of complete this. And after that, I'm gonna go deploying this in a Docker container. So after that, we just need to run 2 commands, basically, which we just copy paste them. That's pretty much it. And immediately now should be done. Yep, that's it. So let's build the Docker container based on the Docker file we have already here. So as you see, is kind of basic. So it's using a minimal image from from Red Hat, and it's exposing 8080 in the container to the outside world. So we created the Docker container. But let's check it if it's already here. So we have the container created. Let's also run the container. So, and that's the first thing. So this is a native image created. And if you look at the startup time, right? So the startup time, it's ridiculous, right? You kind of, it's hard to actually believe it, that it's really performance of a Java application, right? And if we look at the browser, so we should be able to access this Quarkus, and we have the access point already here with our message, right? But we kind of created a basic structure. Now I would like to kind of extend a bit the extensions that we have. So right now we have just basic stuff. I'll add a bit more into this, and I will explain what those extensions are doing. So I'll add this set of extensions. And these two extensions will be used for the Spring support. So kind of have the annotations for Spring to kind of use the Spring as you like to use it. We have something from the SMORI, the implementation for micro profile to document APIs. We have Hibernate with Panache for fast development over Hibernate, so to kind of expose, so to play a bit with the database, with H2 implementation in memory to be fast on doing so, and the serialization, of course. And we're going to look a bit on how do we do remote calls to this. And remote calls, that's why we kind of put in the container. So we're going to do some remote calls to that container we've done, and we will look a bit at fault tolerance if will time allow to do that. Okay, so the first thing, since we have everything here, we save it, we need to kind of refresh this in the Maven side to kind of have everything reloaded. But of course, so these are manually added by me, but if you kind of look on codequarkus.io, you have all the extensions here as you have for Spring initializer, and yeah, you have commands to be able to copy that, all the dependencies you want to use. You have documentation attached to all of those. So I'll not go into details about that. We have everything imported here. The next thing that we should do is to change the port that we expose, because in container we have 8080. So let's expose for this 8000, let's say. And you have also maybe a nice thing, you have dev profile, which kind of you can set different ports even if you are going in dev mode, right? So let's have a different port for dev mode, a different port for production mode or for final operation. And now let's look a bit on the dev mode. Vn Quarkus dev, and in this way we kind of start the dev mode of Quarkus. So from this point on, we're not going to need to restart again. We're going to just change content, and we expect everything will going to work out of the box. Going to take a bit of time, but after that we should have, being on the dev mode, we should have in the browser accessibility to the 7777, I think we added, right? We're looking at this, so very fast to show you that we already have Swagger. So Swagger, it's already available with the endpoint we already have, so no additional coding we need to do. We already have Swagger in place. What else here? We have each extension that we use can have support or to kind of monitor them. So you kind of see each component exposing data. So you kind of have a in-depth understanding about what's happening with the extension in the system at that point. But yeah, so let's move to coding and maybe do something with the database. So the first thing, let's do an entity. Let's say a person entity, let's put something, and we're going to use for database, we're going to use Panache. If you are not familiar with Panache, basically this is an extension of Hibernate that it's giving you some already implemented methods. So somehow similar with Spring Data. Yeah, similar with Spring Data. So we're gonna rely on Panache to do our entities. Let's put something here. Let's put some age as well. And normally we need to define this as an entity, but I will not do it now, just to see how errors are handled. Let's say, let's create a DB resource. Let's give it a path. Let's say DB, right? Let's do something with this. Let's do a get, so to kind of get do a list of so to get a list of persons for our application, for our entity. Sorry. Let's say application JSON. Let's say public. This will be so a list of persons, right? So get list or something like that. And let's return person dot list all. Let's say also have a sorting here, ascending by, let's say, age. And that's pretty much it. We need to import the list. And what else? We're gonna need to add some object as well. So let's do a post. We produce, and also we should also consume some JSON. How should we call it? Public response, right? At person, something like that. And we have a person. All right, and what we need to do is persist this and return an entity response dot status. Let's say a status created and entity person, right? Dot build. So that's pretty much it. So we've done the entity, we have it here, right? Probably we need to do transactional on this one as well, but let's look at what happened, right? So we are not restarting anything. On the refresh, we're gonna get some updates, and we're gonna have already the endpoints, right? So no refresh, no restart, no nothing. We've done some new entities, some new classes, but we don't need to do anything. If we hit on get, and right, so if we try to do get, we have an error. But so exception you get always, but what you get here, it's saying that Panache entity needs to be an entity annotated, right? So you kind of get a hint about the exception directly in the code. So what I need to do, it's basically what it's telling me to do. So to do entity here, I save it, I refresh it, I look again, and execute. And that's it. So we have an empty list. We don't have anything in the database, right? But let's do a post now. Let's try to add some entity in our database. Let's try it. Let's put it generic. If we look again, we have an exception. But if we look at the exception, it's saying that we don't have transactional, and we should have transactional on the method. So it's already advising us that we should be transactional with this. So let's do it transactional, right? We save, we refresh, we try again, right? Let's do it like, I don't know, real, this time 45, execute. We have an entity in there. Let's say 22. Oh, come on, execute. We have it there. If we look on the get, let's try it out, and we have two entities sort by age already. So you see the hints that we get from the coding point of view, quite neat, and you kind of do a lot of productivity gains because of that. And the next thing I want to show you very quickly is to show you how we connect to the remote service we already have running. I'll create for that another Java class, which needs to be an interface. So to communicate, we're going to need an interface. Let's say remote service for this one. And we need a couple of annotations for that as well. So we need to register as a REST client. We need to provide a path. We need to provide a path for that, of course, and let's keep it. So register client, we're gonna go to the endpoint where this URI should be. Base URI of this should be something like for us local HTTP local 8080, and the path for that will be hello, I think it was. Right, and if we look here, we need to do a method get produces, and this produces media type, and this is text for us. Let's say public string is this one, get remote. See. So this is an interface, and how do we actually use this one? It's quite easy as well. So to do usage of that, we need to create a remote service here, annotate this with REST client. Okay, and okay, and if we look at this method that it's already used, we can adapt that to say return here, like the structure. Let's put it like that. Return service dot get remote, right? So to get it from remote. Let's see if we have this after refresh. Hopefully we have it. Let's go in the root to kind of see again the Swagger points and see this one. Try it out, execute. So you see, we get it from remote. The only thing I still want to show you, it's fallback, so the fault tolerance, so how the fault tolerance works with this. So let's say we put a bit more magic on this one. Let's say we have a fallback method for this, and fallback, let's use just the fallback method. For us, let's call it fallback. So this will be the fallback method we want to use, like this. Let's put it like this. Fallback and public string fallback, and soon return from fallback. So yeah, that should be it. Another refresh. If we go here, if we execute, we are still on that. But if I kill the container from remote and I execute again, I should get some timeout and return from fallback. Right. So that's pretty much it. What I think we had time to show for today. I had a bit more prepared, so to kind of show you how Spring stuff, it's working, but it's quite straightforward as well. So yeah, not much different. But what I wanted to highlight, it's the productivity you can achieve, and this fast hot reloading, together with the hints that you get on when you develop, they're quite nice for going very fast, productive with things with Quarkus. Um,
Excellent. Thank you.
so I think that was welcome, welcome. I had a bit more to show, but yeah, the time is not in our advantage, I would say. But I think the people kind of get the idea of how fast you can develop with Quarkus and how easy it is to adapt to, let's say, productivity changes. And live reload can work as well on remote servers, so you can kind of have a deployment on a Kubernetes cluster, which you don't usually have on your local machine running easily. So you can go with Kubernetes on AWS and have the instances for developers there, but you have boot reload on local machines, and you kind of see it on spot on the cluster how things are behaving, which is not so easy to achieve in the world of microservices with other solutions. Yeah, so productivity is not so easy to achieve when it comes to microservices deployments.
Indeed, that's why everybody says out there, yeah, don't use microservices just because they're microservices and it's the hype right now. Make sure you actually need them because they come with overhead. But
Of
really
course.
insightful. And well, what can I say? I think we should have a part 2 session next time at Codecamp. I'm quickly looking at the questions. Maybe we can tackle them in 2 minutes because some of them you already, let's say, touched a bit upon. Um, One would be, for instance, what do you think about Spring Boot native versus Quarkus?
So on performance-wise, I think they are quite on par. So at least from what I've seen with regards to performance of this, but extension is the problem. So the core of Quarkus and the core of Spring will be kind of similar, but you kind of end up with things like, what do you do if you want to use an external library? Is that supported or not? And Spring at the moment, what is with native is kind of supporting the ecosystem they have, but not going outside that. What Quarkus is doing at the moment is has a lot of support on AWS, so S3 connectivity or things around that are not really in the core solution. So I think par on par solution is kind of maybe will be similar performance, but extension will gonna drive. So usually in a productive system, we don't have only the core stuff, you also have a lot of technologies around it that needs to work. And native, it's a must to work on all technologies. So if you go on Graal VM, both of them are going to Graal VM. But when you go to Graal VM, things need to work in total. So everything you have in the binary needs to be compliant with Quarkus, with Graal VM. If it's not like that, you need to do tuning on that particular component to make it native, right? And Quarkus is kind of picking the tools. You kind of restricted to the tools, so you can use Jaeger for tracing. You cannot use others because they are not supported. But if you use that, it's given that you're going to be native with that.
All right, so there are some limitations, at least for the moment.
Yeah.
Um, Next, I think here's an interesting one. So, Keycloak, I think, yeah, they were saying they're migrating from Wildfly to Quarkus. Do you expect other frameworks or tools
Uh,
to move this way?
not necessary to move, but to have compatibility with native components. So if they will have compatibility with native components, so I think everyone, everyone will gonna have native concern on their tooling. If they will move to Quarkus or not, I think it's a matter of taste. I think it's awareness rather, but at the moment, development experience on Quarkus for me, it's a nice thing to have. And I think the others will gonna raise the game. So Spring will gonna raise the game in that direction to make it better for developers to develop on. And that's just a, let's say, a raised bar on Quarkus, which gonna the others will gonna take probably in couple of months, if not year.
Great. And let's say one last question. Do you encourage using Quarkus with lambdas?
Ooh, yeah, yeah.
That's that's an easy one,
That's
right?
yeah, 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 yeah.
All right, Rel. Well, thanks a lot. It was great having this session and discussion. And until next time.